Alright, we're going to continue on in graphing here. First thing you might see for equations of lines, they're called linear equations. The first form you'll see them in is called standard form. I guess we could just use this. Standard form. Standard form looks like this. And if you want to see an example with real numbers, they replace the A, the B, and the C. So here's a real example right here. Now this is the easiest way to graph equations. As long as you know what an x-intercept is and a y-intercept is, you can graph an equation in this form pretty easily. First step is to set or substitute, say that x equals 0, and solve for y. So what does y equal if x is 0? Well, let's substitute. 2 times 0 is 0, right? And we still got that 3y there. So 0 plus anything is just what's left. So we only got 3y equals 12. Well, we can solve that by dividing both sides by 3, right? So y is 4. Alright, so instead, oops, let me get my eraser. Y is 4. Okay, second step is to do the opposite. Set y equal to 0 and then solve for x. So we'll have x equal something here. Let me erase what I did here. Hopefully that's good enough. So I still have 2x, but now I have 3 times 0 because I substituted y, put 0 instead of y. 3 times 0 is 0, right? Let's fill in everything else. Well, that leaves us with 2x equals 12, and so if we divide both sides by 2, then x equals 6. Alright, let's get our graph out here. So just pay attention to these values over here. This is what we're going to graph. So when x equals 0, I'll even just make your coordinate pairs here. X is 0, y is 4. That's our first pair. Our second pair is x is 6 when y was 0. Okay. So graphing that, 0 on the x, we don't go left or right, but we go up for 4. So there's, call that A, doesn't matter. And when x is 6, 1, 2, 3, 4, 5, 6, and we don't go up or down, so we stay right there. That's our second point, point B. And we can easily just connect the dots, and we got ourselves a line. And so that's graphing in standard form. That's all you have to do. You find where the graph, if x was 0, where does it intersect the y? Well, at 4. And if the y is 0, where does it intersect the x-axis? Well, at 6. And so we know at least those 2 points on the line, and we can connect 2 points by a line. Now, if we knew the slope, so if we know that we go up 4, so we rise over run, right? We go up 4, we go down 4, right? This is a negative slope. Go down 4 and over 6. Well, then that must mean that our slope in reduced form would be negative 2/3. And we could use that slope to figure out more points. We could go down 2 and over 3, and there's another point on our line. And if we want to go backwards, we just do this in the opposite. So we need to go left 3 and up 2. And that makes sense, right? Because from this point to this point, we use our slope. Down 2 over 3, so that's still part of our line. We could continue that forever. However, if we weren't able to do that, I guess, if we didn't know how to do that, there is an equation we can use if we know 2 points on a line, like the ones we knew using our standard form. We could solve for the slope. Let's say we didn't know the slope yet, but we did know these 2 points. We know 0, 4, and 6, 0. Okay, 0, 4, and 6, 0. Remember, this is our x and our y. Here's our x and our y. Why did it just draw that line? I don't know. Ignore that. If you remember that if we're given 2 sets of coordinate pairs, well, we got to name them. We got to be able to distinguish this x value from this x value. So we start giving them sub-names, which are numbers that go below the thing. So my first pair I'm going to say is x1 and y1. That's my first pair. My second pair I'm going to say is x2 and y2. And I can use that to find the slope. Here's our slope formula. It's y2 minus y1 over x2 minus x1. And now all we do is substitute these values that we already named here. So instead of y2, I'm going to use 0. Instead of y1, I'm going to say 4. And instead of x2, I'm going to say 6. And instead of x1, I'm going to say 0. If we note that equals 0 minus 4 is negative 4, and 6 minus 0 is 6. Well, if I reduce that, I still get negative 2/3, and that's the exact same as what I already figured out up there. So either way, you can figure out the slope. As long as you know 2 points on a line, you can use the slope formula. So that's a good little trick to know. Alright, I'm going to clear all this away. Start over again. Start talking about something else. Alright, the next thing we're going to talk about is slope-intercept form. Slope-intercept form. Slope-intercept form looks like this. Y equals mx plus b. Remember that m is our slope. The y and the x are just coordinates in our coordinate pair. And this b right here stands for the y-intercept, or where my line is going to cross the y-axis or intersect the y-axis. So let's do an example here. Let's say that something was in standard form and I didn't know how to use it. All I knew was slope-intercept form. Let's try negative 3x plus 4y equals negative 8. Well, we know that this equation right here has to be y equals, so we're solving for y. And if you remember from algebra, how to do that is to get rid of everything or undo or do the opposite of what's happening, move things around, so that y is the only thing on the left side. In order to do that, we have to do PEMDAS backwards. So we're going to take care of this addition right here. We're adding a negative 3x. Well, to undo that, we need to add a positive 3x to both sides, right? So on the left side, we're left with 4y. And over here, I'm going to put the 3x first, and I'll explain that in a second. I guess we can explain it right now. We'll see that the slope in the x has to be first in the form, so we might as well just write it first just to save ourselves the trouble. Last step is to get y by itself. Well, 4 times y, in order to undo that multiplication, we have to do division, but we got to divide by 4 on everything here. So on the left side, all we're left with is y, which is what we want. And now we have 3 over 4x. I want to leave it that way because it's a slope. I want to leave it as a ratio. I want a rise over a run. But negative 8 divided by 4, I can reduce that. What's negative 8 divided by 4? Well, it's negative 2. And so now I have a form that I can graph. I'm going to rewrite it right here just so that when I open up my graph, hopefully I can see it still. There we go. Oh. Let's try and move this in. Stop it. Move over. There we go. Alright, so that should be good. Now if it's in this form, I have everything I need. Remember that last number is the y-intercept, or where my graph crosses the y-axis. So if I can find -2 on the y-axis, I can put a dot there. I know my line is going to touch that or cross it. So that's definitely a point on my line. And then from here, well, I can just use the slope to figure out the rest of the points. So if I go up 3 from here, 1, 2, 3, and over 4, 1, 2, 3, 4, then I know that's another point on my line because I'm using my slope. You can keep using your slope. 1, 2, 3, 1, 2, 3, 4. Keep going up 3 over 4. You can even go backwards, so do it in reverse. If I go left 3 and down 4, 2, 3, 4 right here. Make sure I count right. Alright, 1, 2, 3, 1, 2, 3, 4. Yeah. Oh, whoops, I did it backwards. I need to rise 3, so go down 3 and over 4, so I'm really right here. So it's always good to check. I noticed that my point wasn't quite in line and there was something wrong, so always good to check, reevaluate things. Now I know that all of these points are on my line, I can connect them and I have a line. You can draw arrows if you want. And if I want to check this, let's say that all I did was I started with this and I wanted the equation for this, well, we can always work backwards. We start by looking to see where it crosses the y-axis. Well, it crosses it at -2, so I know that -2 is going to be my y-intercept. And then, well, find other points on the line that are easy to locate, so points that are right on those little unit markers are the easiest. You can always take 2 points. Remember, we got our slope formula if we need it, if we can't count it, or if we want to make absolutely sure. We could use that, take 2 points to find the slope. Or we could just count. 1, 2, 3, goes up 3, rises 3, and 1, 2, 3, 4. It runs 4. So the slope is going to be 3 over 4. But let's check and make sure. Let's use this point. That's 0, what is that? 0 on the x and -2. And let's use this one. This one is 4, 1. So I'm going to use this for my x1 and y1. So let's just plug that in there. Let's see. We'll do it over here. So 0. That's my x1. And my y1 was -2. And this is going to be my second pair. So 4 is the x2. And the y2 is 1. And let's see what we get. We get -1 over 4. That's not right. Well, we're wrong. Let's check. It's always good to check. So this is x1 is 0. I'll put that there. This is y1, -2. Oh, I see right here. This is a common mistake. There we go. 1 minus -2 is going to be a +3. Positive 3. Positive 3. There you go. So see how it's always good to either graph and use your equations? That way you can always double check and make sure you're absolutely right. So that's the slope-intercept form. I'm going to have to end this video and continue on the next one. Again, checking your answer. Doesn't matter if you come across a little error. As long as you have the intuitiveness to figure out that you were wrong and like what went wrong. Well, let's figure it out. Let's either graph it and count, or let's do the slope-intercept form, and then we can figure out what mistake we made. See you in the next video.